In this video, we're going to cover the peak emission wavelength of an LED. And in this photo, we can see the setup. The camera is over here. Spectroscope is in the middle. And here on the right-hand side, there's a compact fluorescent light, which will be used to calibrate the scope and camera using the method that was described earlier. In the same frame, we also see the helping hands here holding a LED, in this case a yellow LED, and it will be powered by a bench power source that's out of the frame here. So the procedure goes like this. Calibrate with the compact fluorescent light. Take a spectrograph of the yellow LED and then check the calibration again to see if it's moved. So after calibration, here's the spectrograph that we get from the LED, and in this case it's a light-on LTL2V 3YX3KS, and it just so happens that I have the data sheet for it, note the wavelength that we get here. Here's the data sheet, and again the same LED from light-on, and this particular spectrograph shows the relative intensity here on this axis from 0 to 1 versus wavelength. And through the magic of Photoshop, I can bring in the spectrograph that we were able to record and superimpose it in red over the spectrograph from the last slide. So we see it's in red here, and I did measure the wavelength to be 593 nanometers. And if we look at a table that I took from the same data sheet, we find that it gives peak emission wavelength and the dominant wavelength. Now, the peak emission wavelength is the wavelength where the emission spectrum reaches its maximum as detected by a photosensor, like we're doing. And the dominant wavelength is the single wavelength perceived as maximum by the human eye. So the LED, as you can see, has some spread here, and our eyes, our brains can turn that multiple wavelengths into a single color, which differs somewhat from the peak that's measured by a photosensor. And what we should be comparing to down here is the peak emission wavelength of 596 nanometers versus the measured 593 measured here. So in this table, there's a min, a typical, and a max, and they don't give a min and a max, but we're within 3 nanometers, so that seems reasonable. I do think it's interesting that the measured spread of the LED spectrum is tighter, smaller in our measurement than it is in the data sheet. The other thing is, this seems a little strange. The blue spectral line here from the data sheet, it says the peak's at 596, but this point here is to the left or less than 596. So there's a slight discrepancy between, as I see it, this graph and the value that's given down here in the table. So that's our evaluation of spectral wavelength. Hope you enjoyed it.